Everyone, Akil from Oxen Academy here. This is part 3 of our related rate series, and today we are going to talk about the ladder problem. So let's go ahead and get started. A 15-foot ladder leans against a tall building. The ground is slippery, causing the ladder to fall. If the top of the ladder falls at a rate of 12 feet per second when the foot of the ladder is 9 feet away from the wall or building, how fast is the foot of the ladder moving? So let's go ahead and interpret this problem with the diagram. So this right here can be, now it's not a very straight line. This right here can be our wall of the building and ground. And I'm gonna go ahead and fix this line as well. Just like that, cool. So let's go ahead and draw in our ladder. So this right here is our 15-foot ladder. Let's go ahead and call this length right here, the 15 feet, let's call that capital L for now. And we also know that at the base of the ladder, we're going to call this a coordinate point 90, because the base of the ladder, or the foot of the ladder, is 9 feet away from the base of the wall, which we're going to call 0, 0. But this right here, this top of the ladder, we're going to call this a coordinate point, but we're going to call this 0, 12. And you're probably wondering, where did I get that 12 from? Notice something here. This right here, this ladder leaning against a building, this sort of resembles a right triangle. But what kind of right triangle? Notice, this base is 9 feet, and this length, or hypotenuse, is 15 feet. If we have a triangle with a base of 3 and a hypotenuse of 5, if I go ahead and draw that out right here, if we have a base of 3, a hypotenuse of 5, this height right here has to be 4 because it's a 3, 4, 5 triangle. But notice, what if we multiplied all of this by 3? We would get a triangle that's 9 feet, 15 feet. That's a hyperbolic triangle right there, whoops. 9 feet, 15 feet, and 4 times 3 feet, which is 12 feet. And notice, that's exactly what we have here. We have a base length of 9, hypotenuse of 15. Therefore, this right here, height is 12. And that's where we got that point from. So, we go ahead and draw in our given rate, which is that the top of the ladder falls down at a rate of 12 feet per second. But notice something, if it's falling down, we typically think of that as a height decreasing. If the height is decreasing, that means that the rate must be negative. So this right here is actually negative 12 feet per second. And this rate, which I'm going to indicate with an arrow as well, we're going to call this rate dx dt. And we don't know what dx dt is. We're solving for dx dt. Now, what we need to do here is we need to sort of find an equation that relates all of these given quantities in one. And that equation is actually the Pythagorean theorem. And let me show you how. So, if we go ahead and write in our Pythagorean theorem, x squared plus y squared equals L squared. If we go ahead and do what we need to do, implicitly differentiate this, we notice something here. X changes with respect to time, so we have to use implicit differentiation. By using implicit differentiation, we get 2x times dx dt. That's just how implicit differentiation works. Repeat the process with y because that also changes with respect to time. That's 2y times dy dt. And this is equal to, notice, L does not actually change with respect to time. Why? Because it's the length of the ladder. If y is changing and x is changing, the ladder is simply slipping. And so if we go ahead and draw another point right here, or just draw another point that the ladder's at, this length is still going to be 15 feet. So if L is a constant, that means L squared must also be a constant. Therefore, the derivative of L with respect to time, that's just 0. So the derivative of L squared with respect to time, that's also 0. So let's go ahead and simplify this out a little bit. So we have a 2, and a 0. We can say that's 0 times 2. That's not really relevant though. So we can go ahead and divide out a 2. And let's go ahead and substitute in our given quantities. So we know that x is 9. So 9 times dx dt plus y times dy dt. Well, we know that y is 12 and dy dt is negative 12. So this gives us 12 times negative 12. This is equal to 0. If we go ahead and move all the non-dx dt terms to the other side, we get 9 times dx dt. This is equal to negative 144 moved to the other side. That's going to be positive 144, just like that. and divide both sides by 9, we get that dx dt, this is going to be 16 feet per second. And it's positive 16 feet per second because we know that it has to move to the right because the length does not change. So yeah, that is our answer, and that concludes the ladder problem. This is part 3 of our related rate series. That's Akil Garpare from Oxford Academy signing off, and I hope to see you in future videos.